Hi there, Miss Barber here. This lesson is titled Antiderivatives. Many operations in mathematics have reverses, addition and subtraction, multiplication and division. In this lesson, we learn how to find a function from derivatives. This reverse operation for differentiation is often called antidifferentiation. The process reconstructs the function from the derivative. For example, we could construct a velocity function from the acceleration function. Let's begin with a definition. A function, capital F of x, is an antiderivative of a function, lowercase f of x, on the open interval from a to b if uppercase f prime of x equals lowercase f of x for all x in that open interval. Let's explore this. Find three different antiderivatives of f of x equals x cubed. Hint here is ask yourself the question, what function or functions can you take a derivative of to get the function f of x equals x cubed? Well, when we take the derivative, we lower the power of this by 1. So my first attempt would be, how about if we let cap f of x equal x to the fourth? Then, when we take the derivative, cap f prime of x equals 4x cubed. That's not quite x cubed. We've got that constant of 4. So how about if we divide by 4? So for my second attempt, I'm going to say let f of x equal 1/4 x to the fourth. Then when we take the derivative, cap f prime of x would be equal to, we've got that 1/4 times the derivative of x to the fourth, which is 4x cubed, and that gives us x cubed. Yay, that checks. We have a function like this. We need 2 more. So let's consider the question, the derivative of what is 0? The answer? Any constant. So how about for our second function, I'll keep f of x equals 1/4 x to the fourth, and I'll make it plus 7, just add any constant. When I take the derivative, capital F prime of x is equal to 1/4 times the derivative of x to the fourth, which is 4x cubed, plus the derivative of 7, which is a constant. That's 0. And so we got x cubed. That works just as well. We still need one more function. Let's go back to the derivative of what is 0. We answered any constant. So we'll let the third function, the f of x equals 1/4 x to the fourth plus c, where c is any constant. Then when we take the derivative, capital F prime of x is equal to 1/4. The derivative of x to the fourth is 4x cubed plus the derivative of any constant is 0, which gives us our desired x cubed. This process of adding 1 to the power of x and dividing by that number, I wonder if it generalizes. We previously showed that any two functions with the same derivative on the open interval from a to b are equal up to a constant on the same interval from a to b, and the derivative of any constant is 0. Thus, the general antiderivative of f of x is 1/4 x to the fourth plus c, where c represents a constant. Example, find an antiderivative of f of x equals cosine x. What do we know about derivatives? Well, we know that the derivative of sine x is cosine x, and we know that the derivative of cosine x is negative sine x. So, answer the question, the derivative of what function is cosine? Well, the derivative of sine is cosine. Thus, the antiderivative of f of x equals cosine x is sine x plus c, where c is any real number. Let's get some rules. Theorem. If uppercase f is an antiderivative for lowercase f on an interval I, then any other antiderivative of lowercase f on I has the form uppercase f of x plus c for some c that's a real number. Let's get some definitions now. Definitions. The general antiderivative is also called an indefinite integral. The constant c is called the constant of integration, but we usually just call it constant. And we have a rule, the power rule for integration. For x raised to a power of p and p is not -1, the general antiderivative is given as x raised to the power of p plus 1 divided by p plus 1 plus c. Know this rule by heart. More rules of antiderivatives. Remember, the purpose of an antiderivative is to undo derivatives. So these rules, they're just the reverse direction of the derivative rules you have already learned. An uppercase letter represents a particular antiderivative of the corresponding lowercase letter. We've got two general rules. If you have k times lowercase f of x, then to get the antiderivative, it's just that k constant times the antiderivative plus c. Similarly, if you have two functions f of x plus or minus g of x, to get the antiderivatives, you find each of the antiderivatives separately, then add them. Then we have trig rules. Let's in particular look at the antiderivative of the cosine of ax. That's 1 over a sine of ax plus c, provided a is not 0. Let's see what it looked like with derivatives. That is, if you wanted the derivative of 1 over a sine x plus c, the derivative of sine is cosine, so we have cosine ax. The constant 1 over a stays put. Using the chain rule, you must multiply it by the derivative of ax, that would be a, and then plus the derivative of the c constant is 0. That simplifies to cosine ax. Look at that. It matches, it goes in the reverse direction. Take the time to do this for all remaining 5 trig rules. Example, find all functions f where f prime of x equals 2x to the 5th plus 3 sine x. To find these functions, we compute the antiderivative, which we can also call the indefinite integral. Let's find the antiderivative. We'll begin by using the power rule for the integration. We will have the 2 stays put for the constant, then 1 over 1 plus the power, which was 5, times x to the 1 plus the power, which was 5. Continuing to the right, plus 3, that's the constant, times the antiderivative of sine x, which is minus cosine x, plus constant. We always have that plus c. Let's proceed with the arithmetic. So we'll have 2 times 1/6 x to the 6th. We'll move the negative from inside the parentheses to the left of 3, so we'll have minus 3 cosine x plus c. One final step of arithmetic left. 2 times 1/6 would give us 1/3 x to the 6th minus 3 cosine x plus c. That's our function, f of x equals. Let's check. That is, let's take the derivative of the function we just got. F prime of x would be 1/3 times the derivative of x to the 6th, which is 6x to the 5th, minus 3 times the derivative of cosine x, which is minus sine x, plus the derivative of the constant c is 0. Perform some of the arithmetic and we get f prime of x equals 2x to the 5th plus 3 sine x. That's what we started with. And so it checks. Next example, find all functions f where f prime of x is equal to the quotient of 12 minus x in the numerator divided by the square root of x in the denominator. We're going to begin this problem with some algebra. We'll do term-by-term division and then apply rules of exponents. What would that look like? Well, let's write 12 minus x divided by the square root of x as 12 minus x divided by x to the power of 1/2. Now we'll do term-by-term division. That'll give 12 divided by x to the 1/2 minus x divided by x to the 1/2. And finally, we'll apply some rules of exponents. That'll give us 12 times x to the power of negative 1/2 minus, and then express that ratio as one term, so that'll be x to the power of positive 1/2. We can then say f prime of x, which is equal to 12 minus x divided by the square root of x, is equivalent to 12x to the power of negative 1/2 minus x to the power of positive 1/2. We can apply the power rule for antidifferentiation here. So we need to find the indefinite integral of f prime of x equals 12x to the power of negative 1/2 minus x to the power of 1/2. While we've got fractions, we're still going to use the same power rule for antidifferentiation. Let's begin. It'll be 12, which is the constant, times 1/1 plus the power, which was negative 1/2, times x to the 1 plus the power, which is negative 1/2. Then we'll have minus 1/1 plus the power, which is positive 1/2, times x power to the 1 plus 1/2, and then remember the plus c. I'm going to do each step of the arithmetic as we simplify this. In our next step, I'll have 12 as the constant, 1 divided by 1 minus 1/2 is positive 1/2. Similarly, that'll be x to the power of 1 minus 1/2 is positive 1/2. Moving to the right, 1 divided by 1 plus 1/2, that's 3/2, and so x is raised to the 3/2 as well, plus c, that stays put. Continuing with more arithmetic, 12 times 1 divided by 1/2, you reciprocate, multiply, that becomes the number 2, x to the power of 1/2, minus 1/3/2, flip and multiply, you get 2/3 x to the power of 3/2 plus c. You can also express this using the root symbol and write it as f of x equals 12 times 2 is 24 times the square root of x minus 2/3 times the square root of x cubed plus c. Example, find all functions h if h prime of t is equal to t cubed times the quantity t squared plus 2t minus 8. We'll do algebra first and distribute the t cubed. That'll give us t cubed times t squared, that's t to the 5th, plus 2t times t cubed is 2t to the 4th, minus 8 times t cubed is 8t cubed. Now we can use the power rule for antidifferentiation. We'll begin with 1 divided by, and then the 5 plus 1, times t to the power of 5 plus 1. Moving to the right, we'll have a constant of 2 times, and then 1 divided by 4 plus 1, t to the power of 4 plus 1 as well. Continuing to the right, you have minus 8, that's the constant. 1 divided by 3 plus 1, t raised to the power of 3 plus 1 as well. And remember the plus c. Let's proceed with the arithmetic. 1 over 5 plus 1, we can write that as 1/6, and then t to the power of 6. Now we'll go plus 2, and then 1 over 4 plus 1 is 1/5, and t to the power of 5. Then we'll have the minus 8. 1 over 3 plus 1, that makes it 4, so 1/4 t to the power of 4 plus c. Final cleanup. 1/6 t to the 6th plus 2/5 t to the 5th minus 8 over 4 is 2, so 2t to the 4th plus c. Our function h of t is equal to 1/6 t to the 6th plus 2/5 t to the 5th minus 2 times t to the 4th plus c. Example. Find all functions w so that w prime of z is equal to z squared minus 2z minus 15, all divided by z minus 5. We'll begin with that quotient, z squared minus 2z minus 15 divided by z minus 5. We're going to do some algebra first, and by that we're going to factor that numerator. That'll give you z minus 5 times z plus 3 in the numerator divided by z minus 5. Now we'll cancel the common factor of the z minus 5 in the numerator and the z minus 5 in the denominator, so our function reduces to just z plus 3. We can write w prime of z is equal to z plus 3. Now we'll compute the antiderivative. We'll use the power rule, and so z, with nothing written, it's understood that's a power of 1. Using that power rule, you'll have 1 divided by 1 plus 1, z to the power of 1 plus 1, plus 3 times antiderivative. We annex the z, and don't forget the plus c. Let's do a quick round of arithmetic, and so we'll write 1 divided by 1 plus 1 is 1/2. 1/2 z to the power 2 plus 3 times z plus c. And that's our w of z.